So today's session, the session was titled as Machine Learning Using Python. So just for 2 hour session, so very small agenda for these 2 hours. So initially, anyway, all of them very much familiar about machine learning. Anyway, I will play some 2 or 3 slides. What's the need for machine learning? Then some of the application. Then there are 2 major categories on the same. The one which is called as supervised, the another one which will be unsupervised. You will be directly focused on supervised learning. Under that, there is an example which will be linear regression with some basic example with a data set. Participant, please mute yourself. Thank you. So supervised learning, under that we will discuss about linear regression, then decision tree algorithm which is supported for both regression as well as classification. So you will concentrate on decision tree for regression as well as classification. Then we will go for random forest algorithm. So decision tree, there is a single tree which helps for regression as well as classification. As the name itself, forest. So we will go for multiple trees to make a decision. So random forest regression as well as random forest classification. There are several set of metrics supported for this algorithm. Here we will take some of the basic metrics with real-time examples. So accuracy, precision, recall, and F1 score with a real-world example. So with a small real-world demo on Python. So this agenda for this 2 hour session starts with a small intro on machine learning. If you have any queries, anytime you can stop me, or otherwise you can just use chat box to message. So start from a small intro on machine learning. So machine can do anything. So what is machine learning? Small intro. So without being explicitly programmed, the science of getting computers to act without explicitly programmed. That's the greatest advantage of machine learning. You without explicitly program, based on the data, the system can automatically learn and act. So based on the previous data, system can automatically learn from the data and then act accordingly without any explicit program. That's the advantage of ML. It's a part of computer domain. So actually the theme was infer knowledge or gather knowledge from data. It was gather knowledge from data. So you can extract the decision making from data. So generalizing to unseen data. So that's a theme. So there is no parametric model, there is no assumptions. So based on data, system can provide a knowledge, provide a decision. That's a theme of machine learning. It's a domain under AI, statistics, optimization, signal processing. So it's a common domain. It can combine all those things and make a machine act accordingly. So there is a small example for machine learning. So you can start from the bottom. So start from the bottom end. 1 second. So this is the raw data. So this one is a raw data. Here the raw data which says there is a red color. Raw data just says red color. Okay. So from that raw data, you can extract the meaning. Raw data just say there is a red color. From the raw data, you can extract the meaning. That is information. The information is there is a south-facing traffic light. The red color, which is displayed on south-facing traffic light on the street. Then from that meaning, you can extract a knowledge. That is context. From that meaning, you can extract the context. The context is this is a traffic light. I am driving towards the traffic light. So that time the traffic light will stand into red. So that's a context. That's a knowledge. From that knowledge, you can apply because the red light was on. So better you can stop the car. This is a dish. So this is what machine learning plays. From that raw data of red color, you can extract the proper meaning or proper information. From that information, you can extract a knowledge. From that knowledge, you can make a decision. That's a theme of machine learning. It's a core behind machine learning. So again, the same intro. So a normal machine, it's merged with some AI techniques. A normal machine which merged with some AI techniques, then that process of that machine, which will be termed as machine learning, which can learn from data, which can predict the future, which can provide the improvement decision too. So that's the theme of machine learning. So a normal system is enough. Even a commodity hardware is enough for performing machine learning process. So you can add some AI, some intelligence. Based on the intelligence, the system which acts as a machine learning domain, which can perform some basic kind of operation, basic mathematical operation on your data. It can learn from data. It can predict the future. It can provide improvement decision too. So this is small intro on machine learning. So machine learning, without any explicit program, the system can act based on data. So the theme of machine learning was extract knowledge from data. Now we are entering into our second part, machine learning, which applies for variety of domains, even for e-commerce, automobile industry, gaming industry, manufacturing industry, and medical diagnosis. So it plays a vital role for all those applications, all those domains. So now we are entering into our core part. So this for small intro, I'm entering into my core part. To start from base, machine learning, the algorithm which categorized into three major types, one for supervised, the second one for unsupervised, third one for reinforcement learning. So under supervised learning, there are two categories, one which is called as regression, second one which is called as classification. We will not focus on unsupervised and reinforcement learning today. We are directly focused on supervised learning. Under that, there are two excellent domains, one which is called as regression, another one which is called as classification. So machine learning, under that the first core domain which is called as supervised learning, from that classification and regression. So regression, you can predict the exact value based on the previous data. You can predict the exact value, that will be called as regression. Classification, whether it's in the class 1 or class 2. Classification is concerned whether it's in class 1 or class 2. So regression is concerned, you can predict the exact value, but classification is concerned whether it's in class A or class B. That's for classification. So here, the regression, which having variety of, it can predict the exact value. So you can predict the popularity of advertisement, weather forecasting, or market forecasting. These are some of the applications. Classification, whether the person is fraud or not, identify a fraud detection, whether the person having a particular disease or not, that is diagnosis. So customer retention, then image classification. These are some of the classification. So these are some of the basic application under machine learning. So there are variety of algorithms, linear regression, logistic regression, LSTM, decision tree algorithm, random forest, then reinforcement, k-mean clustering, KNN, then ANN and Navy Bayes. There are variety of algorithms, variety of standard algorithms which plays a vital role on machine learning. Yeah, now we are entering into our core part. Machine learning, which categorized into two types. The major part which will be focused on supervised learning. The supervised learning, the system can learn from input as well as output. Initially, we can provide both input as well as output. Based on that, system can automatically train, system can automatically learn from the data. Then whenever user can provide a new input based on the already trained metric, system can return a result. That's for supervised learning. I'm entering into the steps involved in machine learning process. So only 5 steps, only 5 algorithm. It's a theme of today's session. So the step number 1, this is a core part. So only 5 major steps as well as 5 major algorithms. That's the theme of today's session. So step number 1, define a problem. Step number 1, to define a problem. After that, you can prepare a data, that is data set. You can choose a proper algorithm. If needed, you can improve the result. At last, you can present the visualize the result in an excellent manner. These are the 5 steps involved in ML domain. Now we are entering into our title was machine learning using Python. So Python is an excellent open source software which plays a vital role in machine learning, deep learning, and all set of domains. So which having variety of libraries, Python having collection of libraries for processing a data. The excellent 5 libraries, the first one, which is called as NumPy. The first library, which is named as NumPy. So as a name itself, the number handling. So we choose to manage an n-dimensional array. NumPy is a package we choose to manage an array. Pandas is a data analysis package we choose to handle data frames. Then Matplotlib. Matplot library, it's a plotting library we choose to visualize our data in a graphical representation. The excellent library which will be called as SciKitLang. All those machine learning algorithms and metrics are available inside this package, SciKitLang. So all those, I think 99% of ML algorithms, standard ML algorithms are available inside this package named as SciKitLang. In addition to that, several set of more than 100 metrics, 100 standard metrics with their functions are available inside this package. So this is an excellent package which holding the algorithms used for data analysis as well as data mining tasks. Then the last one, which is called as Seaborn, that's a data visualization library. Anyway, Matplotlib is enough. Anyway, Seaborn which visualize the data in a little bit excellent way. So these are the 5 excellent libraries which plays vital role in ML design. So the library 1, which is for NumPy, which for handling n-dimensional array. The package 2, which is called as Pandas, which for handling data frames. Matplotlib, which is for visualize your data. SciKitLang for algorithms as well as metrics. Seaborn, visualize data in a little more excellent way. So these are some of the libraries and packages helpful for machine learning. Start from little basic on machine learning in a mathematical way. After that, we are entering into machine learning using Python with 5 examples. That's the agenda for today's session. So first factor, which is called as correlation. The first and major factor, which is named as correlation. I hope everyone very much familiar about the buzzword correlation. Actually, correlation, it's a statistical term, just its association between 2 variables. Correlation, which means association between 2 variables. So the correlation, the statistical measure which represent relation between 2 variables. For example, relation between user height as well as weight, something like that. So the correlation, which will be represented in a simple graph. Here there is a x and y value. The correlation of x and y, both are correlated. So here the correlation line, which is represented by a single slope line. Normally everyone very much familiar about the word y equal to mx plus c. It's an equation of line. So here the correlation which will be represented like this. The very simple example, the correlation which categorized into 3 types. The first one, which is called as zero correlation. There is no correlation between the x and y. Actually, correlation between 2 variables, there is no dependency between 2 variables. That will be called as zero correlation. If there is a positive correlation, Here, if x value increases and y value also increases, if x decreases, y value, if two values are going on the same way, which is called as positive correlation. If two values which will be in a different path, one increases, other one which will be decreases, that's called as negative correlation. So correlation, which is the relation between two variables, here which categorized into three types. One is a zero correlation, the second one which is called as positive correlation, the third one which is named as negative correlation. So positive correlation, for x variable increases, y also increases. If x decreases, y also decreases. I will give a small example. Zero correlation, so there is no relation between two variables. There is no relationship between two variables. 1 second, please. Sorry. So zero correlation, so there is no relation between two variables. For example, here the user height as well as income, there is no relation between user height and income. Drinking tea and the intelligence level, there is no relation between drinking tea and there is no relation between weight as well as student scores in the exam. There is no relation in the shoe size as well as number of movies they watched. So these kind of things which is called as zero correlation. There is no correlation between variables. The second example, positive correlation. Here, if one variable increases, other also increases. If one decreases, other variable also decreases. That's called as positive correlation. Here, this is a slope like this. Here, sale of apartment and the infrastructure. If a building having more facilities, automatically the sales was increased. So the time spent on meeting, if the value of the person in the company was high, then automatically we are spending more time on the meeting. Then improvement in health as well as medical dosage. So these are some of the examples for positive. If one variable increases, other also increases. Then height as well as weight. So this is a simple example for positive correlation. Then ice cream sales and weather temperature. If temperature increases, automatically ice cream sales was increases. So this is called as positive correlation. The negative correlation, there is an opposite direction. The two variables vary in the opposite direction. Negative correlation here, two variables are vary in opposite direction. If one variable increases, the other variable decreases. If one increases, other variable decreases. Otherwise, one decreases, other variable increases. That is known as negative correlation. Here, there is an example for negative correlation. Example was, sorry. So time spent for watching movies, something like that. Automatically, if you are spending more time on watching movies, then automatically your exam score was reduced. More time for spending on TV, exam score was reduced. Time increases, then score was reduces. That's called as negative correlation. This is correlation. Correlation is a relation between two variables. Positive correlation, one variable increases, other variable also increases. Negative correlation, one variable decreases, other variable increases. That's called as negative correlation. So this is a simple example, simple mathematical example. Then we are entering into Python example. So here we are entering into first theme for linear regression. The first and foremost thing which will be called as linear regression. So it's a predictive algorithm which helps to provide a linear relationship which is called as prediction. 1 second. So linear regression, the linear regression in Python, which having two types, one which is called as regression and second one which is called as classification. As the name itself, regression, we choose to predict the exact value. Okay, there is an example. You can predict based on the previous semester result. You can predict the next semester result or next semester mark of the student. So you can predict the exact mark. That's called as regression. Based on the previous classes, you can predict whether the student is pass or fail. Whether the student is in group A or group B. Group A is pass, group B is fail. Whether the student is in group A or group B. That's called as classification. So regression, we choose to predict the exact value, whether the temperature of the today or temperature of the tomorrow. That's called as predict the exact temperature. Whether it's hot or cold. Whether it's hot or cold. You can find the class A or class B. That's called as classification. So you can find either classification or regression. So linear regression under that two domain, one which is called as classification, second one which is called as regression. So predict the price of the house, it's regression. Predict whether the person having disease or not, that's classification. I'm entering into my first Python example. All those examples are live same. So please listen carefully. My first example. So linear regression. So only 5 stages. Python was very easy language. So only 5 steps for creating machine learning algorithm. So please listen carefully. The step number 1. The step number 1. Here this is a step number 1. I mark it as step number 1. So import libraries. Step number 1 for import libraries. So whatever library packages are needed, one which is called as pandas. So import pandas as pd, then import numpy as np, import matplotlib.pyplot as plt. So the 3 packages, one is a pandas for data frame, the second one which is a numpy for handling array, third one matplotlib for visualizing your data. So the 3 packages are imported first. So step number 1 for importing packages, import pandas, numpy and matplotlib.pyplot. So step number 1 completed. Now my step number 2. Step number 2, I have download the data set. Download the data set. At last I will provide the link for all those data set. So you can download data set from this URL. This URL provide the data set which will be named as studentscourse.csv. I have downloaded the file and paste it inside a folder d:/datasets, and I have write a line. Dataset is a handler or variable which is equal to pd is object for pandas dot read underscore csv. CSV is a comma separated value. So you can read the data from studentscourse.csv and which marked into a handler dataset. So dataset.shape which represent number of columns as well as number of rows. Is it clear? So step number 1 for import package, Step number 2 for download data from dataset, and then you can use pd.read_csv. You can read the data from the dataset. So dataset equal to pd.read_csv, then student_scores.csv. You can read the data from dataset. So step number 1 for import packages. Step number 2 for download data from dataset, and then you can mark it as dataset equal to pd.read_csv, then your file name. Then step number 3. This is not step number 3. This is for dataset.headof. We choose to display some top 4 values, top 5 values. So if needed, you can display the data. That's not required. Then dataset.describe of. This is a method we choose to describe the dataset standard deviation, mean, minimum value. So entire thing which will be displayed here. This is also not mandatory. So step number 1 for import package. Step number 2 for read data from dataset. Step number 3. Here this is for just plot. This is not required. Step number 3 for plot data. So step number 1 for import package. Step number 2 for read data from dataset. Step number 3 for preparing data. So 1 for import package, 2 for read data from dataset. Step number 3 for prepare data. Here I have taken it as x equal to dataset dot index location colon, so all rows and columns except the last column. So except the last column, all those columns, for example, my dataset, actually my dataset comprising of only 2 columns. Anyway, all the other columns are taken it as x, only the last column which will be marked it as y. So dataset.iloc 1. So here there are 2 columns 0 and 1. So the first column which is taken it as y. Here also 0, it's enough. Anyway, all other dataset handling we can follow the same way. So you can use like that. So x equal to dataset.iloc colon, so all those rows colon -1. So except the last column, all other columns will be taken into x. Why? Only the last column. Here the last column index is 1. So only the last column which is taken as y. So step number 1 for import package. Step number 2 for read data from dataset. Step number 3. Step number 3. Here step number 3 for preparing data. You can split the data into 2 sets. One is x, another one which is marked as y. All the other columns which is marked as x, only the last column which is marked as y. So now 3 steps are completed. Now the 4th step. My 4th step. Here, actually there are 10, assume that there are 10 data are available. 1, 2, 3, 4, 5, 6, 10 data are available. 10 data, each and every data x and y values are available. Okay. Totally 10 data are available. Each and every data having their own x and y value. I can randomly split 80% of data. Okay. So first 8 data, randomly 8 data which will be taken into training. So that x and y value, the first 8 data, x and y value, which is given for training. After training completed, you are having only 2 data, that is 9th and 10th data. That y value which will be, you can remove y value. You can pass only x value to the trained model. Based on the x data, the model which can predict y predicted value. You can compare y predicted value along with y actual value. Then you can get the result. I can repeat again. I am having totally 10 data. I can split the data into 80% for training and 20% for testing. It's my rule, 80-20 rule. So I am following the same. So 80% data taken for training. So x and y values are passed for train the model. The model was trained. Another 20% data, that is 2 data are available. That y value, we can remove that, and x value passed to that machine. The machine